Hi students, in my last video we have learned whenever A, B, C are reals and A not equal to 0, then the quadratic equation ax square plus bx plus c equal to 0 has the roots x equal to minus b plus minus root over b square minus 4ac by twice a. Students, so we learned when a, b, c all are real numbers and a not equal to 0, then the quadratic equation ax square plus bx plus c has the roots, that is x equal to minus b plus minus root over b square minus 4ac by twice a. Students, let us see some important results from the given formula. These are the quadratic equation has two roots. Let us see three more observations from the given formula. Let us see when b square minus 4ac greater than 0, then the roots are minus b by twice a plus root over b square minus 4ac by twice a and minus b by twice a minus root over b square minus 4ac by twice a. Students, whenever b square minus 4ac greater than 0, so the two roots are real and distinct. Students, let us consider the next result when b square minus 4ac equal to 0. Then the roots are minus b by twice a and minus b by twice a. Students, in this case the roots are real and equal. Let us see the fourth result, that is when b square minus 4ac less than 0. Students, since there is no real number whose square is negative, hence there is no real roots. So we see b square minus 4ac determines the nature of the roots of the given quadratic equation. Students, so we get as fifth result b square minus 4ac equal to, say d is the discriminant of the quadratic equation. So from this quadratic formula we define three conditions. Whenever d greater than 0, the roots are real and unequal or distinct. Whenever d equal to 0, then this part is 0. So the roots are real and equal. And whenever d is negative, that is there is no real number whose square is negative, so the roots are complex or imaginary, or we can say there is no real roots. Students, let us consider the problem. Find the discriminant of the quadratic equation x square minus 5x plus 7 equal to 0, and hence find the nature of the roots. Clearly, the given equation is of the form ax square plus bx plus c equal to 0. Students, the given equation is of standard form where a equal to 1, b equal to minus 5 and c equal to 7. Hence, the discriminant d equal to b square minus 4ac equal to minus 5 whole square minus 4 into 1 into 7 equals to 25 minus 28 equals to minus 3, that is negative. Hence, there is no real roots. Let us consider the second problem. Find the discriminant of the quadratic equation 3x square minus twice x plus 1 by 4 equal to 0, and hence find the nature of the roots. Find them if they are real. Students, the given equation is 3x square minus twice x plus 1 by 4 equal to 0. Here a equal to 3, b equal to minus 2, c equal to 1 by 4. Therefore, d equal to b square minus 4ac equal to minus 2 whole square minus 4 into 3 into 1 by 4 equal to 4 minus 3 equal to 1, that is greater than 0. Hence, d greater than 0. Therefore, equation has two distinct real roots. Therefore, the roots are x equal to minus b plus minus root over b square minus 4ac by twice a. This equals to 2 plus minus 1 by 6. Hence, the roots are 2 plus 1 by 6 equal to 1 by 2, or 2 minus 1 by 6, that is 1 by 6. Students, let us consider the third problem. Find the discriminant of the quadratic equation x square minus 4 into root 3x plus 12 equal to 0, and hence find the nature of the roots. Find them if they are real. Students, here a equal to 1, b equal to minus 4 into root 3 and c equal to 12. So the value of d equal to b square minus 4ac equal to minus 4 root 3 whole square minus 4 into 1 into 12. This equals to 16 into 3 minus 48 equal to 48 minus 48 equal to 0. Hence d equal to 0. Therefore the quadratic equation has two equal roots. Hence the roots are minus b by twice a and minus b by twice a. That is, what is the value of minus b? That is minus of minus 4 root 3 by 2 into 1 equals to 2 root 3, and the second root also 2 root 3. Students, in this case we get d equal to 0. Therefore we conclude that the roots are equal and real, and hence the roots are 2 root 3 and 2 root 3. Students, let us consider the fourth problem. Find the value of k for which the quadratic equation x square minus 4x plus k equal to 0 has distinct real roots. Students, we have to find the value of k for which the roots are distinct and real. Here d equal to b square minus 4ac equal to, what is the value of b? That is minus 6 whole square minus 4 into 1 into k, that is 36 minus 4k. For distinct real roots, d must be greater than 0. This implies that 36 minus 4k greater than 0. This implies that 36 greater than 4k, that is k less than 36 by 4. Hence k less than 9. Hence for distinct real roots of the given equation, given quadratic equation, k must be less than 9, which is the required condition for existence of two distinct real roots. Students, let us consider the fifth problem. Find the value of k for which the quadratic equation kx square plus 8x plus 8 equal to 0 has real roots. Students, here we get a equal to k, b equal to 8 and c equal to 8. So d equal to b square minus 4ac equal to 64 minus 4 into k into 8 equals to 64 minus 32k. We have to find the value of k for which the quadratic equation has real roots. So for real roots, d must be greater than 0, d equal to 0. In these two cases, we get real roots. Hence d greater equal to 0. Therefore 64 minus 32k greater equal to 0. This implies that 64 greater equal to 32k. This implies that k less equal to 64 by 32 equal to 2. Hence k less equal to 2. So for real roots of the quadratic equation, k must be less equal to 2, which is the required condition for existence of real roots. Students, so we learned this quadratic formula is very important not only to find the roots of the equation but also to find the nature of the roots of the quadratic equation. Thank you for watching the video.